Good day, my viewers. It is another time to study mathematics, and the topic we'll be considering this time is longitude and latitude. We want to look at the concept of longitude and latitude. We'll be considering the definition of longitude and latitude, the lines of longitude and latitude, how we sketch position of point or location on a great circle, and how we calculate the distance between 2 points on a parallel latitude and on a great circle. Because most of the time students confuse these two, they just find the distance. We'll do justice to that during the course of this lesson. So what is latitude and what is longitude? Latitude is an imaginary line. You can see it there, that imaginary line drawn around the earth, which shows how far the north or south from the equator. The equator is that line that drawn across the west and the east. It is pointed with arrow labeled at the right diagram, the left diagram we're looking at. So that is the equator. And what the line of imaginary lines that we're having is a latitude. These are latitude and they are imaginary lines. It shows how far to the equator. As we can see, it shows how far the north and the south is to the equator. Now, longitude is an imaginary line that runs from pole to pole, which shows an east-west position of the earth. As we can see, we have the imaginary lines as well, the one that shows the east-west position of the earth that is drawn vertically upward, coming from the north straight down to the south. So that line is also called we call it lines of longitude. So, and the name is called meridian. The line of latitude is called parallels. So the line of latitude are the one that draws horizontally, and the one that is drawn vertically is the lines of longitude. So we have to take careful look at that very well, because as we be proceeding in this lesson, we'll be coming across diagrams that will require us to draw and to identify all those places. Okay, we have a question. We are asked to sketch latitude 50 degree north, longitude 150 degree west, and latitude 50 degree north, longitude 50 degree west. Look at this diagram very carefully. The one that is drawn with black ink is what we first draw, and the one that is drawn with red ink is what we have drawn according to the question that we were asked to answer. Look carefully at that latitude 50 degree north, latitude 50 degree north. So we are drawing it close to the north. In case another question asks us to draw latitude maybe 50 degrees south, we have to draw it close to the south, just as it is. But this one requires us to draw it close to the north, which we have done. And not only that, we are asked to draw longitude 150 degree west, which we have drawn as well. It is labeled there. That is longitude 150 degree west. It is drawn towards the west cardinal point, and we are asked to draw longitude 50 degree west as well. That is what is drawn, followed it. It is 50 degree west. And what we are actually identifying here is 2 points. The first point is latitude 50 degree north, longitude 150 degree west, and latitude 50 degree north, longitude 50 degree west, because they are both lie on latitude 50 degree north. That was why it is just drawn once. So the 2 points are the identical 2 points that we have on that latitude 50 degree north, pointed at with an arrow, and it is rightly labeled there. So this is how we identify, this is how we draw and how we sketch position of a point. We may be asked to walk towards the east as well. East is by the right, west is by the left, north is by the top, as we can see. So as it is given to us, knowing to do well to identify that latitude is drawn horizontally, and it could be towards the north or towards the south, while longitude is drawn vertically. It could be towards the west or towards the east. Now, we want to find the distance between 2 points. After the points have been identified, we may be asked to find the distance between them and get to know this. The concept behind this sphere is that we're going to bring in the concept of circle. The concept of circle will come in place, and as we have heard in our circle, we know that 360-degree complete an oscillation, and there is this derived formula that is being used to find the length of an arc, because as you can see, when we have 2 points on a great circle, we are required to find the distance between 2 points, which means we have to find the length of an arc. So as it has been identified here, we want to find the distance between these 2 points on a parallel latitude. On a parallel latitude. Just like I said, there is difference between finding points on a parallel latitude, distance between 2 points on a parallel latitude, and distance between 2 points on a great circle. On a parallel latitude, it works this way because we are working with the latitude, not the great circle now. If it were to be the great circle, we can see the midpoint of this circle. So it will work with the equator if it were to be great circle. But this one is on a parallel latitude. So we are particular about the one at the close to the north. Now let's see how it goes. This is what we use to find the length of an arc. Alpha over 360 times 2 pi r, where alpha will be the angular difference. What do I mean by angular difference? Is that we want to see what is the angle that is being formed between the 2 points, and how we can get that angle is by taking the difference when they are both at the same cardinal point. But when they are at the different cardinal points, we add them together. So 150 minus 50 is 100. And how do we come about this r? This small letter r, because we are not dealing with the great circle. If it were to be the great circle, then we'll consider the radius of the earth, which is 6,400 kilometers. But at this point, we have to use cos theta, and theta in this case, it will be the angle that is formed, the angle at the latitude. Exactly, the angle at the latitude. So the theta to obtain that cos will be the angle at the latitude. So r is equal to 6,400 cos 50, which you are going to make use of that radius as 4,113.84. That is what we'll be considering, and substituting the value into that formula, and we'll simplify it. The distance between the 2 points on a parallel latitude will now be 7,183. That is on a parallel latitude, just as we have said. But on a great circle, meaning that we are considering the one on the equator, as we have just shown it on the diagram. So we are drawing it closer to the equator. So we'll consider the radius of the earth, 6,400, to find that, because we are working with the one on the equator, which is the great circle, because we always have it that the greatest circle is located at the equator. So the radius we'll be considering there will be 6,400 kilometers. Then we use the same formula to find the length of an arc, just as it has been said earlier. And please take note of how we measure the angular difference. It is because of the fact that they are towards the same cardinal location, the west. That was why we are taking the difference 150 minus 50. If it were to be another example that probably were given to the west and to the east, we're going to add it together because it will expand the angle between them, and the angle between them is what we are considering as alpha. And when we simplify this, we're going to have 11,175 kilometers. So this is how it is, and probably a question might ask us to find the speed or the time whereby one of this magnitude is given. Do not forget that speed is the distance covered per time taken. We can easily take care of that by saying speed is equal to distance over time. So by doing that, we can make use of the distance being already calculated and the time given to obtain the speed. Thank you so much for listening. Do have a wonderful day.